All right. I think that should be going now. Let's. Yeah. Haven't done this for a while, so let's see. See how this goes. All right. So today I'm in the workshop and trying to get some soldering done. Um, Part of what I have is a bunch of these microphones here. So these are MEMS mics. Um, Soldering a whole bunch of these, which are going to go on to these ESP32s for smart speakers. And we'll see how many of these I can get done. I'm probably not going to solder these boards all at once first. I am just going to try and solder the components that I already have. Like I already got one, only got one microphone left. Supposedly, I just got a whole bunch of these, which are the audio amplifiers, um, the DAC chips. And I got 5 of these that just got delivered, so won't be able to do too many of these, but I did get a bunch of audio speakers soldered together. So I think today is going to be just prepping components. This is the main power supply that I'm using. I have this one, which is kind of wired up the way that I want to have it. And then I got this one, which hasn't been soldered together yet. But I'm trying to do that today. And then I have a bunch more of these coming, but I have not gotten them yet. One thing I want to do is to clean up this here. So this is kind of like this is an old version that I've been doing. Previously, I was wiring up the audio amplifier and the microphone in together using the same power supply, and also using the same I2C or I2S connection. But I have I have since changed that because it was causing some problems. But I'm also trying to get a bit of a cleaner wiring in there too. So you can see this is the new one where I've got this ribbon cable. This is silicon wire ribbon cable. This is silicon wire too, but this is, I have a bunch of 3 connector and 2 connector wires, which does work really well because I do a lot of stuff with NeoPixels and power stuff. But now with this having 5 connections. I did want to clean it up a little bit, and so this is what the connection looks like to the board right now. Same thing with my microphones. Is I wanted to clean it up a bit, so using this, it's actually a 6 connector silicon wire. I believe this is, what is this? 28 AWG, and this is the wire that I've been using. It's pretty nice. It is a 6 connector wire here, so I do have to peel one off. The tricky thing with this is that, as you can see, it is all black with just one white line. So the white line is going to be my power connection, and then I do have to keep a very careful track of which ones from the white line. It is I am going to have, usually what the standard I've been using is the white line is power, the one right next to it is ground, and then I just kind of count for the other ones. I have kind of stuck to a standard where the if I'm doing like I2S or anything that requires like data and clock, I have been doing the outermost 2 are going to utilize that. And that's stuck pretty good. I mean, you can see how nicely that looks, where it's nice and straight. The only thing where it kind of breaks down a little bit is you can see on the back of this one, I had to get a little creative with the wires crossing over, but in the end, like, this does a pretty good line for the microphones, and that way I won't have a bunch of wires getting all tangled up when I'm doing the assembly of stuff. So let's see. First thing I want to do is, so I'm also testing out these lithium battery chargers here. I have a whole bunch of them. They're pretty inexpensive, but these just use USB-C. I can connect them to other stuff, but I just want to do some testing with some voltage stuff. So let's see if we want to do that. Yeah, I'm just going to disconnect this trigger here. And I am going to charge up that battery. And what I want to check is what the output voltage of this is. Because ultimately, like, I like these, the Power Boost 1000s from Adafruit. I like them because they include the battery charging on them, as well as the 5-volt, 1-amp boost converter, which bumps the 3.3 volts lithium battery up to 5 volts at 1 amp. But more importantly, it does have like a low battery monitor on it and an enable switch. So I can put a power switch to turn off the boost converter, which is really handy, which means that I can basically put an on-off switch on here very easily. But more importantly, it has the voltage detection switch on it, which is just an analog reading for the battery, which allows me to do a low battery detection, which is going to be really important for this smart speaker, because then that lets me let it announce when basically there is no, when the battery is getting low. and to plug it in, which I think is going to be really handy. All right, so let's see what the voltage coming out of here is, because I would like to find something that does more. Let's see, so that's a little over 4 volts. So honestly, like, that's probably just the full battery in here. I was having a little bit of trouble with overheating with these things on chargers, but I wasn't too sure if I wasn't wiring up incorrectly. There's not a huge amount of documentation on this, and the writing on it is a little confusing. So I have a feeling that I was wiring those up incorrectly. This seems like the correct one, and I'm not getting any excessive heat off of that. Of course, the more alarming thing was that the battery was heating up on some of these, which can give battery damage, but it seems to be doing fine now. Let's go ahead and disconnect that and see what. All right, yep, still getting about 4 volts. 4 volts usually indicates that the lithium battery is full of charge. It will drift down to about, generally it ranges about 3.3 volts. It does drop a little under 3 volts when it starts getting close to when the protection circuitry on here will kick in, and you will no longer be able to draw anything out of it. That's kind of a safety precaution with a lot of the lithium batteries. And let's see. So these are the magnetic connectors that I have been using. You can actually see them right there. So it's that little magnetic connector there, which lets me do a magnetic power cable. So that way, if you are connecting this, let's see, where do I have this? It's connected through that one. So I got these USB cables that has the other end, and what I do is just connect them like that, and they just pull off nice and easy. You can see my indicator lights here going on, indicating that it is charging, and when I disconnect it, it's not charging. So that is just a nice little thing that I wanted to do for this, so that when you have it charging, if you walk away with it, you don't have to worry about like tearing out the cord accidentally. Those connectors are a bit pricey compared to just regular barrel connectors or something like that, but I mean, it's not that much more, and I honestly like the aesthetic of it. So what I'm going to do is make a couple more of these. I do want to prepare for tomorrow when I am going to have a few more. I don't think I'm going to make them quite this long, because what happens is this is actually just the audio DAC amplifier, and this needs to be connected to the microcontroller but you can hook up a speaker to here with just 2 wires. So if I need length, then I can get length with that. I don't necessarily need this much length. I think I did more of this because this is for a different form factor that I wanted to get a little bit of distance away from the microcontroller. But that's not really going to be the standard. I do want it to be rather close. So I'm going to go, what is that, maybe about 2 inches. I do have 5 that I will have tomorrow, but I am going to rework this one. So I am going to cut 6 of these. 1, 2. Silicon wire is really great because it's very flexible, very heat resistant, and it's a little more expensive than vinyl coated wire, but especially for things that have gone in like wearable stuff, this has done super duper well for that. What is going on here? This feels a little wonky. Okay. All right. Those are my 5. I'm just going to check on something real quick. Okay. All right. Like I said, it's been a long time since I've done the Google thing, so just want to check to make sure that is going. All right. So another thing that I am going to fire up is this guy here, the molten pot of solder. That one comes in super handy when I am doing a bunch of wire connections like this one. It is one of the investments that I did a while ago. It comes in super handy so that I don't have to use my little soldering iron in order to do a whole bunch of stuff like this. Like these wires where I've got, let's see. So 1, 2, 3, 4, 5, 6. Okay, I only need 5. So I am going to remove the last wire as far as I could find. I could not find any 5 connector ribbon cable, at least not at the volume that I am buying it at. and the supplier that I'm getting it at. So it was just easier to get the 6 connector wire, and also if I need to get 6 connectors, then I don't have to buy any more wire. So I can take my auto stripper and strip the ends off. This is where I do want to take a bit of care in what I'm doing, because I want these wires, this is stranded wire, and I want these wires to be as straight as possible for the next step that I'm about to do, which is to tin all of these wires and get them ready to be soldered. All right, let's see if we are ready. Nope, not quite yet. Just gonna go ahead and get the other side of this as well. Do this auto stripper. Some of the parts in there. There we go. Yeah, this one's really great. It is a little bit more aggressive, but for the silicon wires, you do need the more aggressive blade to cut through them. Works out really well. Let's see. Got the edges are starting to get hot, but not quite yet. So what I can do, whoo, that is really warm. All right, so what I can do though is to start removing this. There we go. Don't need that anymore. All right, let me get rid of some of these scraps here. I actually do want to cut some more for this microphone. These I am doing a little bit longer so that I can move the microphone away from the board a bit, but we don't want that to be super long. Because apparently the signal does get affected if you get longer. All right. That should do it. Let's get rid of the one wire at the edge. So that'll be for the microphone, and 1, 2, 3, 4, 5, 6 for the speaker. So I can get this one, and then I'll handle the other 3 tomorrow. Let's see how we're doing now. Oh yeah, that is nice and liquidy. So this is just a big pot of solder, and it's not really useful for a lot of things except for exactly what I'm doing right now. So what I'm going to do is this is some flux, and I just dip a little bit in that, and then dip the tips in there, and they're all perfectly tinned. So make sure wires are all lined up, put a little bit of flux, tin my wires. That's done. And I basically just do this. So this would take forever to do with a soldering iron, because remember that is 5 connectors. It's a little wonky. That's 5 connectors on each side, which would be 10 wires basically that you'd be soldering. And I tend to have my small tip on my soldering iron just because I usually solder some small components, and it does really well for small components. But when I'm wiring or when I'm pre-tinning just a crazy amount of wire ends, that becomes very time consuming. But you can see how fast I am doing all 10 of these per wire, and it's perfectly pre-tinned. Of course, the pre-tinning is really important because it will keep the strands of wires together. And also, it makes it easier to solder. So with soldering, it's a combination of the heat and the metal, which makes an alloy. But in order to do that, you gotta have real high heat. You gotta have the resin provides a lack of oxygen for corrosion as you're soldering, and then it makes an alloy metal. So with this pre-tinned, there is already solder on here. It already has the coating of alloy metal on it. So it is going to take far less time and less heat to join this connection to the component than it would if I did not tin it. And of course, heat is kind of the enemy to electronics, so we do want to make sure that we're using as little heat as possible. So the way I want to wire up this microphone is I want to separate the 2 power and ground cables, and then I am going to flip this over and look at ground and VCC. So I'm going to use the white one for VCC and ground next to it. I just need to get these. I know that's probably very difficult to see from the camera, but I'm separating those wires so that I can get them into their little holes there. Actually, I'm going to bring out this little soldering clamp here. And so that's got it lined up for power and ground. I'm just going to clean up that solder and go ahead and connect that. Well, that one for the power looks a little bulgy. Might be a cold solder joint. Hit it with a little bit of heat, and there we go. So now I got power and ground there. I'm just going to go ahead and snip off a few of the ends. And now I'm going to double check to see this one. So I got power and ground. They are twisted, and then I'm going for SD, which should be the next one over. These microphones are a bit tricky because of their layout. Okay. So now I got SD there. Gonna solder that one together. Hit it again. Yeah. So what I'm looking for is for the solder to kind of sink in and form a nice Hershey's Kiss style around the wire, which tells me that I got a good solder joint and should expect good connectivity. Now double checking my master again. I have the outer black wire going to SCK. So outer wire going to SCK, so this just goes right on over to the other side. Geez, I almost need tweezers to get this in there. I swear I will be glad to be able to move to doing components with a reflow oven so that I don't have to do this tiny work by hand. funny thing is this, on the scale of stuff that I usually work with, this is actually pretty large. All right. Yep, those solder joints look good. I just want to check it with my other ones to make sure. Yep. Let's go into that one. Let's go into that one. Yeah, I think that's looking pretty good. All right. So there is another microphone. So we got lots of microphones. Currently, I only have 3 of these ESP32S3 boards over here. I do have a bunch of other ESP32. I believe they're the C2 boards, which will work for this, but it's not optimized for like the smart speaker stuff that I want to do. So it doesn't have quite the processing power as these guys have, but they work pretty well. Put these back away, and now I am going to move to the speaker here. All right. So the speaker DAC is pretty straightforward. The only one that I do have to separate out is the power and ground. Might be a little hard to see, but you can see there's a little bit of a gap between the pins. So speaker and ground have to go into 2 pins that are farther away, but thankfully they're lined up so that I don't have to twist stuff. So I'm gonna clamp this wire in place. Yep. And this one is going to be a little tricky, I think, until I get at least one of these soldered in place. Actually, you know what I'm going to do? I'm going to try on this other side. So I'm going to try something else because this one already does have some solder in 2 of the pins on the other side. And what I'm going to do is take my solder sucker here. I'm going to clean out one of the holes. Let's do that to it. Yes. So now what I can do is I should be able to spread these guys out enough and get one of these soldered in place. And then at least my board won't keep falling over. Ooh, that is a tight fit. It's kind of hard to get these lined up. Let's see. Get these all going. I think I got a bit of a wire split here. Let's see if I can clean that up. Oh yeah. This is a problem that happens sometimes is the wire just kind of feathers as it's going in. Let's see if I can get this one. All right, so that one. I think is going right in. Perfect. Yeah. All right, let's split these up. This does usually go a lot faster when I don't have something that's already been soldered. Yeah, let's get that in there. Let's get that. Lined up. So hopefully, I just hit that with some heat. Should just slide right in. Almost. All right, got it started. Not quite reaching it on that side. There we go. Okay, now I got it going enough to the other side. Got that in place. All right, so at least it's holding right now. And I'm going to clean that up. Make those solder joints look nice and shiny. So I don't have to worry about cold joints. Cold solder joints are basically solder joints where it did not create a solid enough bond, and they're definitely something that you want to avoid, because basically what they mean is that you're going to have a less efficient connection. And considering that these connections deal with very low voltages in signals that use low voltages, you want to make sure that you're getting the best possible connection that you can through your solder joint. Otherwise, you can end up with very odd errors with your signals not quite coming through like you would expect them to. And they're never fun to troubleshoot. Hop to that wire. No. All right. Well, that one didn't go all the way in, but let's see if we can coax it in a little further. I just don't like having the extra wire. But this is going to get sealed anyways. So I feel pretty good about that. All right, double check that with the one that I know works. Yep, yeah, everything's good. Cool. So I got another speaker connection, and I'm going to use these components to do a bunch more of those speaker DACs tomorrow. Now, next thing that I am going to do, let's see, I got a couple more of these NeoPixel rings that are coming, but I'm not going to do too much with that right now. I think I'm going to do a couple more of these power magnet connectors. Unfortunately, these guys only come with 2 of these, so it has a bunch of pogo pins. So there's 2 sides of this. They are magnetic and they're polarized, so you can only connect them in one direction. If I try to do it in the opposite direction, they actually repel each other. So there is only one way that these connect together. There is one side that has a couple of pogo pins for making the connection, and the other side just has some flat connectors. For the power supply, so the one with the pogo pin is the one that actually comes from the power supply, and this one's supposed to go into the thing that you plug into. So this is actually the one that I want because I'm not assembling my own custom USB cables. I actually found a really nice USB 5-volt power cable that has this built into it, and way better with injection molding than I am able to do here in the shop. So I'm going to stick with that. But what I can do is connect wires to these, which are going to go inside of my smart speakers. And for that, I am going to use some of my 2 conductor wire. So I'm going to cut off some pieces of my 2 conductive wire, and these are marked with a tiny red dot on the positive side. And so I am going to put the wire with the white line on the positive side with the red dot. And as you can see, having that hot pot of metal makes it super easy to get these wires tinned. Oh. Looks like it got a little ridging at the tip. I think I saw bridging over here too. Definitely do not want bridging for these since they're going to connect to lithium batteries. All right, I'm going to trim those wires down a little bit because there's not much room to put like an insulator on here, but that's okay because this gets sealed in with a little dollop of glue, which is going to encase these solder connections anyways. So I am just pre-soldering the side with the red on it. And then I'm going to bend these wires out a little bit and get the positive side connected. Oop. These are tricky because it's got a pretty strong magnet on one side, and as your soldering iron gets a little close to the magnet, it tends to pull that solder tip right onto the magnet, which doesn't help me solder. But as long as you're careful and deliberate, it's not that difficult to do. It does help that this soldering stand does have some metal on it, so they are connected with a magnet to at least keep them from moving around. Those joints look pretty good. Let me go ahead and solder on the ground now. Flow that solder in. Do the other one. There we go. All right, let's take a look at that. I think I might need to hit the power with another one. Actually, no, that looks pretty good. Pretty solid joint there. Solid joint there, yep. So those look pretty good. And that is another component that is ready. You check that with the ones that I already have. Yep. There we go. Those are all good. All right. Don't need that anymore. Someday I am going to have to find company that just sells the female ends of these because they ship them with male and female. All I need are the female ends of them. Seems like kind of a waste to throw them away, but I haven't found a supplier for that yet. So that is how it goes. All right. So I have those going, and let's see. I think I am going to bring up my wiring diagram and see about putting a couple of microphones and speakers onto these guys. So let's see. We are going to go speaker. Let's see. So it's mostly going to be on this side of things. So let me go ahead and clamp that down. And let me move a couple of things over on my screens. Okay, so what I'm going to do, speaker. Eight, 6, 7. So my speaker is going to be, let's see, we're going to separate out power and ground again. And data in is going to go pin 8, 8, and then 7 and 6. All right, so I'm going to separate out the data pin. I think I'm going to do, so LRC is the power one. LRC is 6 and BLCK is 7. LRC, aha, okay. So this is going to go like this. All right. Let's go ahead and tack this in there. Get this nice and snug. Don't want a lot of extra wire sticking out because these connectors are pretty close. I do like these boards because they're pre-tinned as well. All right, so DIN goes to pin 8. Wish that these pins were a little closer together. But unfortunately, this is the configuration that I know works. So I am happy to stick with that for now. Tap in. Nice and snug. Make sure my joints are looking good. Yep. That's good. I'm going to save power and ground for later because there are a lot of power and ground connections. And those are going to go into some bigger junctions. So I'm going to leave those for now. So those are the critical 3 connections for the audio DAC. I am going to now go for one of the microphones. So going microphone goes SD. Okay. SD432. So again, going to separate out power and ground. All right. So we're going 432. That is unfortunate that these are all over the place. So I'm going to separate all of these. And let's see. So SDK or SCK. So SCK is pin 2. I'm going to do that later. All right. So WS goes to pin 3. Let's go get that there. Makes it very tricky to do this when all the wires are the same color. But that's why I've got my sheet over on the side to make sure that I am doing this correctly. So I'll get a little bit of extra stuff there. Let me trim that. Okay. So pin 3, that's S. That's WS. WS is pin 3. Yep. This is where having extra fingers would be really, really nice. I think I can do it like that. Thankfully, these holes are also pre-tinned. Alright, so that just tacks it in place. I'll clean that up in a little bit. Power and ground. I believe this one is the L or the SD. SD goes to 4. Let me just make sure. Yeah, middle connection SD, which goes all the way over. To pin 4. Yeah. Get these other wires out of my way. There we go. Into pin 4. Tap this in. Bunch of solder and then push that wire all the way through. Give it a nice connection, and then now that will hold the rest of it in place. I can go back in, clean up this wire. Oh, got me a little wire bridge. Got that fixed. I'm just going to clean that up just a little bit. Snip that one. That one. That's pretty good. Okay, now we need this, which I think I'm going to take through here. And just to make sure, this one should be my SCK. Let's see. Actually, no. I'm going to do the smart thing and get this through here. So this can just flop right over the edge. So SCK goes to pin 2. Other side. There we go. Oh. Dang it. Okay. Let's try that again. I'm going to bend that over so it doesn't fall down. And then tack that over here. So this is the challenge of using development boards. is sometimes the pin placement is not exactly where you would like them to be. Ideally, I would love it if I could just line these ribbon cables up and not have to split them apart and turn into this tangled mess that you see here, but that is just how it goes sometimes. All right, so these are going to be like that. Let's see, ground. I'm just going to go ahead and try and twist those ground pins together. I'm not going to worry about that too much for right now. Okay, so next thing I want to do is do the LED strip, which is going to require a 3-wire connector, which I thankfully have a bunch of this 3-wire connector here. You know what? I might as well just, since I've got my thing here and I am getting more of these, I'm just going to go ahead and prep a bunch of these wires too. So I got one ring now, so I'm going to do 6 of these. Just because I know I got the components coming, and it does take a long time to heat up that pot of solder. Okay, that's 4. I cannot tell you how much I love this silicon wire over like years of dealing with the vinyl wire that typically is used. It is just so much better. Oh, I think I need to get some of the slag from my solder. That is kind of the thing about keeping this hot metal pot is you just end up with a bunch of slag that gets on the surface, and it kind of gloms up some of the wires. So it is ideal to get these things prepped and do a bunch of them all at once. So then you get the molten solder and don't have to deal with a bunch of the slag. I don't remember how hot that one gets, but well over 200 degrees. See? I don't even remember what the settings are. But yeah, it is very, very hot. I think it's like at 600 or 700 degrees. Oh, I love just how quickly I can do these wiring harnesses. Honestly, with as much soldering as I do, especially with like wire connections like this was a wonderful investment. Literally has saved me hours and a lot of solder too. There's a lot of waste solder when trying to solder or tin this many connections. All right, so those are all done. Pre-tinned wire connections. So typically my standard for neopixels is I do white is power, center is signal, and the far end one is ground. So I am going to separate those two. Basically, I'm going to separate all of the wires. Sometimes it is harder to separate. So I'm going to just do a little tiny cut to get started. There we go. Okay. So main one that I am concerned with is the signal wire. So signal wire on here is going to go to pin 9. And pin 9 right here. There we go. Get that. Tack. Feed it through. Perfect. Clean that up a little bit. There we go. And there is the neopixel signal wire, power and ground. All right. Now, other thing that we're going to do is a digital switch. I'm going to use my thinner 2 connector wire. Those up there for the new pixels. This one usually goes pretty long. So that I can put that push button. So this is used for push button feedback. Currently, the push button in the smart speaker allows you to prompt it to listen without having to use the wake word, just like you've seen me demo in a couple of my videos for the NaviPal. And then also, it if it is speaking for too long, you can just tap it while it's speaking, and it will just stop the audio player. This was mostly done because my testing of this device was getting to be a bit annoying to my husband, understandably so. I do have to do a lot of testing for these guys, and sometimes that prompts some really long responses. I also don't want to have to wait for it to finish before I do more testing. So it was just easy to set it so that it'll stop. All right, I'm gonna move this out of the way for now. To get these ready. I love these auto strippers. Let's go ahead and skim the slag off of this. Nope. Gotta do the flux first. So, like I said before, you have to do flux because it will not stick to the metal. The solder will not stick to the metal unless you have the flux on it. That is why my skim tool is a metal spike, but I don't have to worry about dipping it into solder because it has no flux on it. And if it has no flux on it, it means there is a tiny layer of oxidization on there. And that will prevent the solder from bonding with the metal. So it does kind of stick to it a little bit when I kind of skim the solder, but you might notice that when I tap it, it just comes right off. Wow, that's not good. I'm going to redo that one. Got some of my stranded wire fanned out, and that does not make for a good tinning thing if I got a stray wire. I did tin that one? Yep. All right. So those are all tinned. So I am going to go ahead and grab a bunch of momentary push buttons here. And I'm just going to solder these together. I have a bunch of different form factors of these. I think for this set, I'm going to go ahead and use the orange buttons. Yeah, I'm going to do a mix. I'm going to do the orange ones and some black ones because I think I'm going to use some of these to make some of my dumpster ones. Let's see, how many do I have? 1, 2, 3, 4, 5, 6. I'm going to do 3 black ones and 3 of these orange ones. There is no difference between these other than some are black and some are orange. Otherwise, these are just pretty standard momentary push button switches. Nothing super special about these. Actually, in fact, I'm going to get rid of 2 of these pins. Usually the way these work is it's got 4 of these connectors, and basically these 2 are separated from each other until you push the button, but the one on the other side, those are connected. So there's some nice tricky things you can do to avoid vias on a circuit board by utilizing them, but I don't need them for these. So just not get confused, I'm going to just remove the 2 on the other side because I am only going to be using one of these. These are just standard input buttons. So essentially what I'm doing to them is one end is connected to ground And the other pin is connected to a digital input, which is set to be pulled high. And then that way, when the button is push, it pulls that pin to ground, which pulls that pin low. And I can detect when that pin goes from high to low. And that is how you do a button push detection. You can, of course, do it in reverse, and I could connect that to a 3-volt pin, but unless you got a specific reason to do that, I usually like pulling my pins to ground. With these, it doesn't really matter which one is which, because it's literally just going to connect to ground or not to ground, so it's less important knowing which one of these wires is which. But it is nice to have that anyways. So I'll put these under the little pins. Yeah. Free my solder here. And these are spread wide enough that like I don't need to seal them with any shrink wrap or anything. Kind of like the power supply thing, these are going to get glued into place, and that is going to seal the connection. And there we go. Now I got a push pin ready to go. With my particular application, I don't need to have these in any particular orientation. So I'm just not going to pay that much attention to which orientation these are in. But that's not always the case. Sometimes it is a lot better to pay attention to that. Just not in this case. So that's why I'm just kind of throwing these things on there. Does not matter to me which way they go. Pull those up a little bit. I'm going to try and do it at least so I can see the white striped side in case I do run into a situation where it does matter which one is which. Actually, I'm going to do the smart thing, and I'm just going to set these all up and then just hit them all with some solder so I don't have to keep putting things down and picking them up again. And that. These are actually push buttons that are meant for surface mount, or not surface mount. This is meant for three-hole or through-hole components. I do have some of these buttons for surface mount, but I do like the through-hole ones because I have these nice tabs that I can use to bend over, like you're seeing me do right now, to just hold them in place. These are actually pretty big buttons compared to the surface mount momentary push buttons. There we go. All right, those are done. And now I'm just going to hit all of these with the solder. So one thing you might have noticed is that I am not using flux to solder these on here like I would be for the wire. That is because there is a tiny amount of flux in this solder that I'm using. That is the little bit of smoke that comes out. Of course, that smoke is why I have the fan that you probably hear running in the background. To pull that resin smoke away from me and into a carbon filter. I actually have that tied into the Home Assistant server that runs my office space. And it is on a smart switch along with my soldering iron and a routine. So as long as the soldering iron is on, that fume extraction fan turns on as well. And after I turn my soldering iron off, it doesn't turn the fume extraction fan off until about 5 minutes, I think, after. There we go. So now I got a bunch of push buttons. And yeah, I think that's getting to be close to what I have to do here right now. That is going to set me up really good for tomorrow. I think I'm going to do a little bit of programming stuff right now and a little bit more cleanup around the workshop. Kind of debating soldering these guys together, but I think I'm going to do that another time since these are actually for another project. And I have enough of these to get the ones that I currently have wired up. And so I'm going to stick with that. I got 3 more of these coming hopefully by Friday. And that should do it. So that's it. Thank you, anyone who has watched this. Didn't see anyone in chat, but I know I've done this. Haven't done this for quite a while. So see you later.